When wiring multiple receptacles in a row, it is crucial to understand how the current flows from one outlet to the next. Receptacles wired through terminals utilize the terminal screws to pass the voltage from one receptacle next in series to the next one. In this diagram, we have four 120 volt 15 amp residential electrical receptacles wired in a row. Each receptacle is connected to the next one using terminal screws, creating a continuous flow of current through the circuit. The importance of wiring outlets together using the device terminals versus using, say, pigtail splice, while both methods are commonly used, there is a notable difference between the reliability. When outlets are wired together using the device terminals, it creates a daisy chain effect where the current flows through each outlet in a sequence. However, this method can be potentially weak and it has a weak link problem. What do I mean by the weakest link problem? Well, imagine if there was a break or malfunction at one outlet in the chain. This could be due to many factors, and in such a scenario, the flow of the current to all outlets that follow will likely be interrupted as well. This is where the importance of proper installation comes into play. It is essential to ensure that each connection is secure and that receptacles are in good working condition. In conclusion, while wiring outlets together using the device terminals can be convenient and an efficient method, it is essential to be mindful of the potential weakest link problem. By following proper installation procedures and practices, we can ensure the safety and reliability of the electrical system in residential spaces. This diagram shows the wiring of the same multiple receptacles in an arrangement that connects each individually and to the source using a pigtail splice. This wiring allows for source voltage at each outlet independent of the others in the circuit.
Here, a 3-wire cable is run from a double pole circuit breaker providing an independent 120 volts to two sets of multiple outlets. The neutral wire from the circuit is shared by both sets. This wiring is commonly used in a kitchen circuit where two appliance feeds are needed, such as a refrigerator or microwave in the same location and/or countertop receptacles. Only a 2-wire cable is required for a run to the last receptacle. As you can see, the 3-wire cable red wire feeds 120 volts to one receptacle, while a 3-wire cable black wire feeds 120 volts to another receptacle. This allows for efficient use of cable wiring and protection, as a 3-wire cable can supply a total of 30 amps to various loads. This, however, only requires the installation of a double pole single throw 15 amp breaker back at the panel. I go into the details and theory of this type of an arrangement in my courses that is available on my Stand Store, the link of which is provided at the end of this video. As its name implies, a split receptacle is just a plug which is essentially split in two with a separate circuit supplying power to the upper portion and lower portion of the plug in the outlet. Here, a 3-wire cable is run from a double pole circuit breaker providing an independent 120 volts to 3 of the receptacles. The dotted lines around each receptacle represents the metal box containing each receptacle. 14.3 and 14.2 NMD cable connects these metal boxes as shown. The 2 hot screws on the receptacle are joined by a breakable solid connection. This solid connection can be twisted off with a pair of pliers, separating the 2 brass screws. This is known as a split receptacle. Each plug on a duplex receptacle is on a separate circuit, as indicated with the blue arrows in the diagram. Each can support 15 amps. Notice that the last duplex receptacle in the group is not a split receptacle. Hence, only one 14-2 cable needs to be run to this receptacle. This graphic dramatically shows what happens with a split receptacle. Breaking the connecting bar between the two brass or hot screws of the receptacle electrically separates the bottom from the top of the plug. The red and black wire each carry 120 volts to neutral to each of the plugs, even though the potential difference between the red and black wire is 240 volts. This is because the red and black wires are connected to a double pole single throw 15 amp breaker back at the service panel. As I explained before, I will go into more detail and more of the theory in my course that will be found on my StandStore course, the web address which will be presented at the end of this video. As the title screen of this video suggests, this is the second installment of my DIY house circuit layout and connection series. In this series, I'll be covering essential topics to help you understand and manage your home's electrical system safely and efficiently. By the end of this series, you'll have a knowledge and the confidence to tackle your own electrical projects and ensure your home's electrical system is running smoothly.
Future topics to be covered will include panel wiring. Learn how to properly wire your electrical panel, including identifying circuits, connecting breakers, and ensuring proper grounding. Receptacle connections. Understand the wiring and installation of duplex receptacles, GFCI receptacles for added safety, and AFCIs to protect against electrical fires. Appliance receptacles. Discover how to wire 20 amp, 30 amp, and 50 amp 240 volt appliance receptacles for various household appliances. Light switch wiring. Master the basics of wiring light switches, including single pole, 3-way, and 4-way switch configurations for controlling lighting throughout your home. Stay tuned for up-and-coming videos where I'll dive deeper into each of these topics, providing step-by-step instructions, safety tips, and troubleshooting advice to help you successfully complete your DIY electrical projects. Don't miss out on future installments of my do-it-yourself house circuits, layouts, and connection series, and empower yourself to take control of your home's electrical system.
You can directly access my StandStore courses at this website, https://lowercase stan.store/uppercase G, uppercase V, uppercase B. This is the end of this second video.